All right, so right here, this is determined from the problem. So this is what we want to prove / conclude. So which direction do we want to, okay? Now, the alternative is called a one-sided if it states the parameter is larger than the null hypothesis or if it says that it's smaller than. So these two right here, right, are one-sided tests. When we have this one right here, when we have HA and it's not equal to, this is a two-sided test, or you'll call it a two-tailed or one-tailed. It's a two-sided. Okay, you might also see this as two-tailed. Okay, or one-tailed testing. Okay, so that means that it can be on either side. The difference, it just has to differ from it. It doesn't matter the direction. Hypothesis always refers to the population, not a sample. Be sure that the H0 and the HA are in terms of population parameters. So remember that that has to be either, that's either going to be P or mu. That's what your hypothesis is going to be stated. It's never correct to write the hypothesis with a sample statistic. So this is not correct. Either one of those are not correct because you're using a sample and a sample notation, and it's always written with population notation. So here's an example. It says, does the job satisfaction of assembly line workers differ when their work is machine-paced rather than self-paced? One study chooses 18 subjects at random from a company with over 200 workers who assembled electronic devices. Half of the workers were assigned at random to each of the two groups. Both groups did similar assembly work, but one group was allowed to pace themselves while the other group used an assembly line and moved at a fixed pace. After 2 weeks, all the workers took a job satisfaction test. Then they switched the work setup and took the test again after 2 more weeks. The response variable is the difference in the satisfaction scores, self-paced minus machine-paced. Describe the parameter of interest in this setting. Okay, so the parameter of interest here, notice, is the mean mu in the differences, self-paced minus the machine-paced, in job satisfaction scores, and the population of all assembly line workers at this company. That's who we're interested in. State the appropriate hypothesis for performing the significance test. All right, so the idea is that the mean difference is 0. Okay, because the initial question asked whether job satisfaction differs, the alternative hypothesis is a two-sided. Okay, that is either less than 0 or greater than 0. For simplicity, we write it as not equal to 0. So the null is that the mean difference, there is no difference. That's what that 0 means when we actually do this, and we set this equal to 0. That's telling me that there is no difference in job satisfaction. Okay? This means there is a difference, and we don't care which direction it differs. We just want to know if it differs. So that's why we set it up as the null is the mean equal to 0, because we're talking about the difference. The null hypothesis for H0 states the claim that we were seeking evidence against. The probability that measures the strength of this evidence is called a p-value. Okay? It's the probability, p-value, probability. Remember, probability means area under the curve, so we're going to get probability, so eventually we're going to get area under curve. That's where we're going with this, because we know that when they ask for probability, they're really asking me for area under the curve, and that is going to be called our p-value. Okay? So the probability computed, assuming H0 is true, that the statistic would take a value as extreme or more extreme than the one actually observed is called the p-value, all right, of the test. So that's the probability that what we actually got or something more extreme could occur given that the null is true. That's your p-value. The smaller the p-value, the stronger the evidence against H0 provided by the data. So the smaller the p-value, the more evidence. That's what you need to remember, that the smaller the p-value, the stronger the evidence. So small p-values are a good thing. So small p-values are evidence against H0 because they say that the observed result is unlikely to occur when H0 is true. Large p-values fail to give convincing evidence because they say that the observed result is likely to occur by chance when H naught is true. So, for job satisfaction, here is our null and alternative. Data from 18 workers gave a mean of 17 and a standard deviation of 60. That is, these workers rated the self-paced environment on average 17 points higher. Okay, researchers performed a significance test using the data and found p-value to be 0.2302. Right? Explain what it means for the null hypothesis to be true in this setting. Okay? In this setting, H naught, the mu equals 0, says that the mean difference in satisfaction scores for the entire population of assembly line workers at the company is 0. Okay? If it's true, then the workers don't favor one work environment over the other on average. So if 0 is true, then there is no, they don't prefer one way over another. So now it says interpret p-value in the context. Well, remember, p-value is the probability. Okay? So this is probability, so this really can be written as approximately 23%, right, of the workers, okay, preferred the self-paced over machine-paced. So this is what they said. An outcome that would occur so often just by chance, almost 1 in every 4 random samples, right, because this is 23%, it's almost 25, which is 1 out of 4. When H naught is true, is not convincing evidence against null. We fail to reject it. It could have happened just 25% of the time just by chance alone. So because it could have just happened that we got this value, then we're going to say that it's not, there's not enough evidence. Okay? So given that this is true. So we cannot prove this wrong. So we fail to reject H naught because my p-value is not small enough. 0.23 is like 23%. The final step in performing a significance test is to draw a conclusion about competing claims that you are testing. You will make one of 2 decisions based on the strength of the evidence against the null hypothesis and in favor of the alternative. You either reject the null or fail to reject the null. If our sample results is too likely to have happened by chance, assuming H naught is true, then we get to reject H naught. Otherwise, we fail to reject H naught.